So I want to talk about non-horizontal asymptotes. These are like oblique asymptotes or slant asymptotes. There are other names for them. So slant would be like a linear asymptote, or an oblique asymptote would be potentially like a curved asymptote. And we'll talk about both of those really quickly. But here is an example. We should be able to look at this expression and go, yeah, there is no horizontal asymptote because 3 is bigger than 1. So what we need to do is figure out what kind of equation it is. And earlier I said you can roughly know what the overall shape is by just doing 3 minus 1 and getting 2 for an answer, and we know that x squared would be the overall shape, so it would be quadratic. But if we want to know specifically where does it approach as x approaches infinity, we can just do some long division. So here is a refresher on long division. X minus 1 divided by x cubed. We've got to have our placeholders. Because this doesn't have an x squared term, I need that in there. Plus 3x minus 4. So now what I need to do is go, how many times does x go into x cubed? Well, the answer is x squared. Now I multiply. X squared times x is x cubed. X squared times negative 1 is negative 1x squared. And now I subtract. Right? I'm subtracting that whole thing. X cubed minus x cubed is 0. 0x squared minus negative 1x squared is positive 1x squared. 99% of the time when students make mistakes, it's in the subtraction area. So let's be careful. I bring down to 3x. How many times does x go into 1x squared? And the answer is 1x plus 1x. So now I multiply, and I get 1x times x is 1x squared. 1x times negative 1 is negative 1x. I subtract again. These cancel out. 3 minus negative 1 is 4x. I bring down my minus 4. How many times does x go into 4x plus 4? 4 times x is 4x. 4 times negative 1 is negative 4. Wow, this turns out that this is actually a factor of our equation. I didn't expect that at all. So this quadratic, x squared plus 1x plus 4 is our, what do they call it? Is our oblique asymptote. So if we were graphing this, we could graph that very specifically. It has a y-intercept of 4. The vertex is at negative b over 2a is at 1, negative 1/2. So it also has another thing here, so, and it's positive, so it's this thing that does that. So whatever our function looks like, whatever the whole thing overall looks like, as x approaches infinity, it needs to be approaching that line. So the limit of this function, the limit as x approaches infinity of this function, let's call it f of x, is nothing more than x squared plus x plus 4. That's the big idea. So you just do the long division, and then you come up with that answer. There is a shortcut called synthetic division that works under certain circumstances. I'll have a link to that as well from somebody else, because it's not the technique I like to use, because it only works in certain circumstances. Okay, thanks.